only one person in Menominee.
Where you going now?
There was one chick in Chico's Falls when we started. No, she's just not even here anymore.
There's a lot of people, like, there's a couple on the stable.
Oh yeah, they
Another, yeah.
Whatever. Messed up. They can fail.
Yeah.
I'm only here because I don't really know how to do that.
I'm just trying to pass this class.
I'm just trying to get done with this. I'm just really trying to be done.
How many weeks do you have? Like 3 or 4?
I think 2 I thought.
Really? No, I thought it was 3.
It's 3. Well,
I hope it's 2.
Had to mentally prepare myself for that last week. Do we have a final?
No.
Thank
I
God.
hope not.
No, we can never do.
Yeah, because all the tests like
Yeah.
one
Yeah.
point.
I got a C on my test night.
I know everybody did.
I don't even know what I got. I didn't even look. I was like,
I got a C plus.
Yeah.
I only got my grade out like 1.2%, so I still have an A. And I was like, holy crap.
What the hell am I doing
my
reading
sister
this?
came home last night.
Yeah.
Most of the time I read it and then like 10 minutes
Why?
later
Why
it's
is
like,
that? Is that a
what
bad
did I
thing?
just do?
Because like me and my sister are completely different.
tells you everything.
That's the
I
same.
can't.
It's the same with the. Oh.
And she's my twin sister.
Oh, you have a twin?
Mm-hmm.
My favorite is
Oh,
my
that's
American
so
government
cool.
class
And
that I take.
I just,
Why don't you
I don't
make her come to class?
She was gonna come, but like,
Yeah,
they're
you
like,
should.
oh,
I just can't.
I can't
Luckily it's not online.
at all.
Oh, that's
Is that
You
bad?
just open up a new tab.
What's the
So like, I got home after a 5-hour shift yesterday,
And I only did that once.
and
for
she's
my
like,
last
I'm like,
quiz.
yo, I'm gonna
I
go
opened
take
it
a
up,
shower.
it didn't say anything
You're not
about
gonna
who
hang
was the
out
first
with me?
president to use
I'm like, bro,
media.
that's
But
stop.
now.
Bro, I was like,
Media-
stop.
media
Like,
bias.
she's like, well, I'm gonna go get some food. I was like from the grocery store. She's
First
like,
test
yeah,
I've taken
because
where
we
I
share a car.
Yeah.
I'm like, bro, I just dropped like $350 on this car.
I only had
You
to
wreck
have
it.
one.
I swear. God, I got no money because I helped pay for college.
Where did she go?
UW River Falls.
You have
That's
to pay for
expensive, too.
college? Is it because you're in international?
Well, yeah, and she didn't save any money for college.
Okay.
And so I saved. I paid for myself.
Online work?
Yeah.
Yeah.
That's weird though that your twin sister is like.
So, I
Sure,
mean,
they're like, is that
first of all, you can't even
And now I have like the next 4 days with her at my
So
house.
if there's a,
And your twin sister is nice, is what you're saying?
there's an alien.
Nicer than me. Yeah, a lot of people are nicer than me, though, Kevin.
All right. I've got down that we're doing page 202. And we had just gotten the we were on the gallium experiment, and let's get the formula again. F of t equals negative, or t to the fourth minus 14t cubed plus 59t squared minus 46t
Kevin, we can't see what you're doing.
minus 37. So yesterday we ended with this. Do you remember what this meant?
No.
That's something to do with
This part right here.
Wow, that's a good.
So I'm up, so I'm down. Yeah. Moves the graph up and down.
the left hand.
This one is the right-hand behavior, right?
Yeah.
The coefficient on the front tells you which way.
Yep, it ends up on the right-hand. Menominee, say something.
Hello.
A little bit more. I'm
Hello?
waiting until the screen changes so that we don't see Chippewa. If you talk or make noise, then we'll see you. Still not switching. You gotta talk more, apparently.
Start singing, bro.
What are your plans?
I don't know why it's not switching.
Oh,
There we go. All right. So, and then you can tell the left-hand behavior because since it's to the fourth power, it's going to end up on the left end also. Question number 2. Based on what you see, how many turning points are there? Or possible turning points. Sorry about that. Possible turning points. 4. Okay. Now there's possibly 4 routes. No, 3 turning points. Right. 1 fewer turning points than. But there's possibly 4 routes. Although it could be shifted up so high that, or down so low that there's only 1 route, or there could be no routes since it's even. Real routes. All right. Based on your answer to, we have to do question A. So compute the average rate of change from 0 to 2. Okay, so we have to get f of t at 0 and f of t at 2 in order to answer that question. So do it, and while you do, I'm going to take attendance. Ooh, I don't know if I took attendance yesterday.
I
19th. Nope, I didn't take it yesterday. Okay, Nick was here yesterday, but he's not today. Michael. He was here yesterday. Marlena, both days. Gavin, both days. Janae, yesterday. Felicia, both days. Nicole, yesterday. Eric. He was here yesterday, right?
Yeah.
Phil.
Here.
Grant.
Oh yeah.
That's a strong oh yeah.
I went to bed at 3 this morning.
Oh, so it's a week. Oh yeah. Do you have to work this weekend?
Yeah, I work night shift.
Oh, okay. So you don't work retail.
No. I work as a machinist.
At where?
As a machinist?
Oh, where at?
It's called Prototype Solutions Group.
Oh, cool. Where were we? Grant.
Yeah.
Both days. Strong, oh yeah. Connor. He was here yesterday, right? Eric's here both days. Laura's here both days. Madeline's here both days. Jessica was here yesterday. Lauren was here yesterday. Jacob was here yesterday. All right. So what did you get for f of 0? Negative 37. Good. F of 1, what did you get? I'm sorry, F of 2? What? 11. So, AROC is, I don't like that pen. AROC is 11 minus negative 37 divided by 2 minus 0. What is that, 48? Divided by 2, so the AROC is 24. So over the first 2 minutes of heating, it's going to gain an average of 24 degrees per minute. B, based on your answer to A, does that mean that the temperature of gallium steadily increases over that time? Well, let's look at the graph. Gallium. So here's the heating curve of gallium. Nope, that's not it. 14A. Here it is. The heating curve of gallium over the first 2 minutes goes from here up to here. Hold it, that can't be. It goes from here, negative 37, up to here, about 11. So over that course of time, why don't we sketch that curve? Okay, so the slope over that time period is from here to here. So the slope is this here. Question. There is in that curve someplace a spot where the slope is exactly that same. Does anybody see where it is? So I'm looking for a spot. Obviously it's not here, right? Because we're almost perpendicular there. Keep going along. Ooh, we're getting close. Right about here, do you see that the slope is almost the exact same? There's a theorem in calculus that says the average slope is going to be duplicated someplace at least one time during any function. Now, could it be more than one time during any spot? Sure, if we would go a little bit further, we might see where it goes back down or something like that. But it's going to be duplicated every time. 4. Use the graph. Oops, so looks like you better start graphing. Use the graph. Calculate the average rate of change from 4 to 5. So t, f of t, we had 0, 2. We're going to need 4 and 5 both, correct? To get the a of t. And the a of t for that interval was 24. Now we're looking for a of t on the interval from 4 to 5. So graph it in Desmos and get those intermediate values. So at 4, we are at 83. And at 5, we are at 83. So I'll just draw that part of the graph here. Here's 4, here's 5. And the slope between those 2 points is
0.
Now, using what we did in the previous one, do you see the spot where now the slope is the exact same? Do you agree it'd be about right there? Because the slope at that point, is there any other characteristic that that point would have besides having the same slope?
Turning point?
Yeah. So a turning point, the slope at a turning point would be 0, right? Because it's not going up, it's not going down, it's not going, it's turning. Okay. Then it says, does this mean that the temperature of the gallium does not change between 4 minutes and 5 minutes? No, it just means if you took a picture at the beginning and you took a picture at the end, you would see that the temperature is the same. Number 5, new function, A of t. We're going to always use A of t to be the average rate of change function. And it's going to be long, because it's going to be f of t plus 1. So in other words, every place we see t in the equation, we have to write t plus 1. So I'm going to get it here, and I'm going to write really small because I got a lot of stuff to put in there. T plus 1 to the 4th minus 14 times t plus 1 to the 3rd plus 59 times t plus 1 squared minus 46 times t plus 1 minus 37. I used up way too much room. Because now I'm going to subtract from that this function, right? Because it says, where is it? Minus f of t. So I have to subtract from it t to the 4th minus 14t cubed plus 59 t squared minus 46t minus 37. So that's on the interval starting at t, ending at t plus 1, 1 minute later. In symbols, we write this the difference quotient. Now, they said this is the average rate of change. Hey, I thought average rate of change was always over something. Well, if you notice, it's going to be over t plus 1 minus t. What do you get when you take t plus 1 minus t? 1. So the denominator cancels out, and that's why we have this A of t formula. I love this line right here. You don't need to simplify your answer. Now, because you guys showed up on the day before Thanksgiving, I'm going to be mean to you and make you multiply that whole. Can you imagine how much work that would be to multiply that whole thing out? First of all, you'd have to multiply t plus 4 times t plus 4 times t plus 4 times t plus 4, then multiply by 14. Then you'd have to multiply t plus. You'd get, hey, here's a question for you. What would the highest power be? T plus t to the 4th, right? Because here we'd only get t to the 3rd. Here we'd only get t to the 2nd. And in fact, the t to the 4th is going to cancel out because there's a t to the 4th back here at the end that we're going to subtract out of it. Use a graphing calculator or app to sketch the graph over that interval. So here is my from 0 to 6. Here is my graph. Now let's look at some characteristics of my graph. So the green one is the A of t formula, the average rate of change. So at this point right here, if you go from here to 1 second later, right, here to 1 second later, the slope is 0. If you go from 4 to 1 second later, the slope is, okay. Hey, what do you think the value at 6 will be of our red function? Since it's kind of covered up. Well, since this is 0, it'll be the exact same as it was at 5, exact same as it was at 4, because each one of those has a slope of 0. So what they're showing you in this graph, I'll get out my ruler and I'll just show you what they're doing. They're saying, I'm going to go from one point to a point 1 minute later, slope is 0. Then as I go along 1 minute later, you can see the slope is getting bigger and bigger and bigger and bigger and bigger. 1 second later from right about here, this is the steepest the slope gets, right? Because I'm as high as I ever am. So this is the steepest the slope gets. Then after that, the slope gradually goes down, 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 until here it's getting really close to 0, right? Then it's 0 here. And then it goes negative a little bit, right? It's sloping down a little bit. And then by the time I get over here to 5, it's back up to 0. So what it's doing is it's making the slope at every 1 second interval all the way along there. Give all the roots of A of t. Well, when is the slope 0? The slope is 0 at 0, at 4, and at 5. That means that our function has the same temperature at 0 as 1, as 4 as 5, and as 5 as 6. Page 203. The factored form of A of t is one of the following. Really? So the t to the 4th is going to cancel out. Well, since that's true, since we know what the 3 zeros are, does that help us figure out what the factored form is? What did we write for the 3 zeros in number 6?
0,
We're at 0, 4, and 5, right? So A of t will be t times t minus 4 times t minus 5, which is this one right here. Why did they need to put the 4 in front? Well, they must have had to get the scaling to work out. Remember we did scaling factor the other day? They must have needed it for that reason. Number D. So here we've got a drone. Anybody own a drone? Yeah, I figured you did.
Good
prices, man.
What's that even supposed to mean?
What's that?
You're like, I figured you did.
Well, because Jacob, he's like into just about everything that is really super cool and fun.
Okay,
So-
makes sense.
What's that?
Good save.
What do you mean, good save? That's exactly the reason. Okay, so anybody ever run a drone? I think they're a really cool thing. I watch like SEAL Team, and then I used to watch this other one that got canceled. But anyway, they have drones over the battlefields now all the time, keeping track of movements, troop movements, and stuff like that. Infrared cameras, the whole 9 yards. A height of a quadricopter drone during the first 9 seconds of flight is given by the function as follows. When is the drone descending most quickly? Well, you could either give the interval or the time. What interval is it descending? Looks like from about 0 seconds to about 6.5. But where along there is the slope the steepest?
3 to 4.
Yeah, right about 3 seconds. Make up a story that describes the flight of this drone. Anybody have a good story? It starts out at 150 feet, and then 6 seconds later, it's down to about 15 feet, and then it flies back up again, right? Page 205 down the bottom. Suppose that the function is, let's graph it, just to see that it works out the way they said that it should. So we have, this is B. So we have here t squared minus 10t, or t cubed minus 10t squared plus 3t. I got to get rid of some stuff here. Okay, so there's the flight of our drone, and it looks like on here that it didn't quite peak. I'm going to click on the graph so that you can see. It didn't quite peak till a little bit after time began. Okay, compute the average rate of change for between 3 seconds and 6 seconds. So I put it on there. Let's do the math for that. 3 seconds to 6 seconds. Well, 3 seconds, we have, just wait, I got to get the T and H of T. So at 3 seconds, it's at 96 meters, and 6 seconds, it's at 24 meters. So what is the rate of change over that interval? What is the slope of that green line? First of all, you better get a negative number, right? Because it's going down. All right, so how do we do it? 24 minus 96 over 6 minus 3 is
72 over 3.
which is 18.
No.
Negative 72.
Yeah, I wrote the negative sign in there. Negative 72 over 3. What does that divide out to be? 24?
4.
24. So it's negative 24 what?
Feet per second.
Per second. Remember, you always take the x-axis divided by the y, or the y-axis divided by the x-axis. And we're talking about the slope right here. And the slope is negative 24. Then it says, compute the slope from 3 seconds to 5 seconds. So 5 seconds is back here. Question, is the slope going to be steeper or less steep? Steeper. So when we compute the slope here at 5, we should get a number that's bigger than negative 24. Well, what do we get for a value at t equals 5? So here's my line t equals 5. At 5, it says h of x is 40. So what's the slope there? Remember, we're doing 3 to 5. So here the average rate of change is 40 minus 96 over 5 minus 3.
28.
28?
Think so.
Negative 28 feet per second. So there is a test question on this. Man, I shouldn't be giving these test questions away while Jacob's taking the test.
I'm almost done.
There is a test question in which you have to see where is the slope the steepest. What's the way to do it? Compute the slope at each one of those intervals and see which one of them is the steepest slope. Now, here is the question for you. They don't ask on the test which one is steepest. They ask which one is the greatest slope. Kind of a stupid question if you ask. I mean, a tricky question if you ask me. Which of these two is greater?
Well, negative 24.
Negative 24 is greater. So I don't like the way they do that because it's a little confusing. It is a greater slope, negative 24, when you're in the negative category. And to be honest with you, I don't remember if it's negative or positive. Then they say, since those are different slopes, what could the drone be doing between 5 seconds and 6 seconds? So here it was going down really, really fast. And then what's it going to be doing between 5 seconds and 6 seconds? Starting to level off, right? Maybe it's giving a little bit more gas so that it doesn't go down quite as fast. I don't know if they power down or if you're driving a drone and you want it to go down, do you give it less gas? Or is there some kind of a...
Yeah, pretty much.
You just give it...
doesn't have as much thrust in it.
Okay. I wasn't real sure how that part worked. Page 206. Derive a formula for A of t. So we have to write really small again. A of t. And we're going to do it the exact same way. So the first thing we do is we need to know what our regular function is. T plus 1 cubed minus 10 times t plus 1 squared plus 3 times t plus 1 plus 150 minus t cubed minus 10t squared plus 3t plus 150. Thank you very much.
Thank you.
Have a good Thanksgiving, unless you're coming to class today.
Thanksgiving.
It's Thanksgiving. I'm giving thanks that I'm not going to show up at your class, Kevin. I have to work tomorrow, and so hasta la vista, baby.
Everyone came in town today, so.
Your family?
Yeah.
They're visiting. They just came to see you?
Yeah, only me. No, they came in from like Fargo last night, so.
Fargo?
Yeah.
Is that where you're from?
No.
Oh,
That's
okay.
where they're from.
Because my sister-in-law lives up in Harwood, which is the next suburb north of Fargo. Here we go. So we're going to need to know T. We're going to need to know H of T. And we're going to need to know the interval to find the A of T. Now, to be honest with you, you could substitute into that formula. It says, hint, your formula for A of X will help. But to me, the easiest way to fill this out would be to use the graph of A of T. Okay, so let's graph that A of T business. I don't know where I got that A of T. Let's just graph this one. Let's see. So A of T equals parentheses T plus 1 close parentheses to the third minus 10 times T plus 1 to the second. Oh, excuse me. Nope. We're not doing that here on this table. I didn't see what the values were on the table. Here's what we're doing on the table. We're starting at 3. And then we're going to see, well, what is the difference between 3 and 6? And then 3 and 5. And then 3 and 4. And then 3 and 3.5. And then 3 and 3.1. And then 3 and 3.01. So what we're doing here is we're finding the slopes of our line all the way along here as we get closer. So we're going to start at 6 here. And we're going to keep on backing up. 5, then 4, then 3.5, then 3.1, then 3.01. So that eventually we're getting closer and closer to what the slope is exactly at the point 3. So let's get in the values here for T of 3. I'm going to turn this off so that we... Oops, I must have it on someplace else. Here we go. Okay, so at 3, it is 96. So let's fill that into the table. H of T is 96. At 6, it's 24, because we had that up above. At 5, it's 40. At 4, we need to get. So our function at 4 is 66. Our function at 3.5 is 80.875. At 3.1, oh, come on now. 92.991. And then at 3.01, I don't know if it even goes that far. Oh, let's zoom in here. 3.01 is 95.7. Okay, so there's our values of our function. So the first one, we're going to do the interval from 3 to 6. Well, we already did that up here, and we found the rate of change there was negative 24. For the next interval, we're going to do 3 to 5. So we're going to, and we took 96 minus 24 divided by 2, and we got negative 28. Then 3 to 4. So it'll be 66 minus 96 is divided by 1, negative 30. For the next one, I got to get out my calculator because I can't do that one in my head. It'll be 80.875 minus 90. Oops, that's not a minus sign. Minus 96. Oops, I forgot to put in parentheses around that. Divided by parentheses 3.5 minus 3. And we get negative 30.25. Then for 3.1, we'll take parentheses 92.991 minus 96, close parentheses, divided by 3, parentheses. Better do it again, parentheses. 92.991 minus 96, close parentheses, divided by parentheses, 3.1 minus 3, close parentheses, and it's negative 30.009. That's for the interval from 3 to 3.1. And then for the interval from 3 to 3.01, it'll be parentheses 95.7 minus 96 divided by 3.01 minus 3. Now, in each one of these cases, I did the denominator, and I wouldn't have had to. I could have just divided the first one here by 0.5, the second one by 0.1, the third one by 0.01. Because that's what you get when you take 3.01 minus 3, 3.1 minus 3, 3.5 minus 3. And I get negative 30. So, as I get closer and closer to 3, the slope gets closer and closer to negative 30. The quadricopter's instruction manual says that the operator may lose control if the drone descends at a speed exceeding 30 feet per second. Does this ever happen? Now, you may be tempted to say that it does happen, but if you notice what's happening on that part of the graph, Okay, the slope here on that part of the graph is 30. As you go back out, you can see that it's actually just gets really close to that. Although I don't like that negative 30.25. Maybe I made a mistake in my calculation there. I don't think so. At time 3, an observer on the ground points a radar gun at the drone and measures its vertical speed. What speed will it show? What do you think? Negative 30 feet per second. Page 14C, 207. How far can you travel on one tank of gas? Does it make any difference how fast you drive? Yes, it does. The faster you drive, the more fuel you burn, and so the less far you can drive on a tank, probably. Right? Everybody agree? Here is a model for fuel consumption. Usually we don't talk about fuel consumption. We usually say miles per gallon, not gallons per mile. How many miles per gallon do you get on your car, Laura? 32. Way to go. Marlena?
On a good day, 25.
25. Anybody have a pickup? No pickups. Jess, what do you get? 38. Whoa. I want to drive her car. On a good day, mine gets 30, my CRV. On a good day, my pickup gets 19. On a bad day, driving against the wind, pulling the boat, 12. How about you guys?
I get like 22 in the cold.
22.
But
So
my car-
temperature matters too, is what you're telling me.
Yeah, in the summer I'll get like 26.
Does anybody else notice that they get better gas mileage? Okay, so each one of us was giving our mileage in miles per gallon. Take your calculator and use the inverse key and tell me what gallons per mile you have. So my car gets 30, and here's my inverse key. And I get 0.03, I burn 0.03 gallons per mile. So what do you get, Sam, on your car?
City driving, I get 0.04 gallons.
0.04 gallons per mile? Is a bigger number in this case good or bad? Bad. It's more expensive. That's one of the reasons why people like it the other way around. Our brains are programmed to think big numbers are good. Madeline, how old are you?
19.
And I'm 59, so I am...
Old.
No, better. You're supposed to say better, not old. Better. Anyway, so that's usually the way we like to think. So you go to the store though, and they will have this thing costs 14 cents per ounce and this thing costs 15 cents per ounce. Which one do you buy? The cheaper one, right? So sometimes we're looking for spending less money. So say you want to go to a shoe store in the mall and buy a pair of shoes tomorrow or the next day, okay? And so Laura says, oh, I love these shoes, but they're way too inexpensive. I want to buy these because I'm going to spend more money on them. Is that what you do on Black Friday? Is you go out and you look for expensive stuff to buy?
I mean,
I'm not going out for Black Friday. Anybody going out for Black Friday? Shopping?
Out to the woods.
Going to the woods. Nobody's going shopping on Black Friday. I'm supposed to pick up my suit on Friday, but I only wear it for funerals, and I don't feel a funeral coming on, so I don't think I'll have to pick it up.
That's what they always say, Kev.
Well, if it's my funeral, I really don't care. Somebody else can pick it up. All right. So here is a formula that shows consumption as a function of velocity. So, how much gas would you burn if your velocity is 0? Well, we could put 0 in here. 0 minus 50. 50 squared is 25,000 divided by 50 is, I don't see how you can burn fuel if you're going 0 miles an hour. It does say that it only works between 15 and 85 miles an hour. So maybe we should stick to that. Question number 1. What's the right-hand behavior of this function? Over here on the right. Over here on the right. What's the right-hand behavior of this function? It's positive. So the faster you drive, the more fuel you consume. Based on the fact that it's a square, what's going to be the left-hand behavior? Since it's a square, it's also going to be positive, right? So what must be happening somewhere between those two high spots? A low spot. Is the low spot good? Yes, the spot where you are burning the least amount of fuel per gallon. Let's graph it and see what we get. Now, I've got the speeds from 0 to about 80, so I'm not worried about that. But why is my consumption so low? Well, I better not be burning 1 gallon per mile, right? So I'm going to set my y-axis to go from about negative 0.1 to positive 0.1. And then it fits on there pretty nicely, okay? I'm going to click on my graph because remember, that's how I get my important values, okay? I'm going to get their addresses. There's only 2 important values. The initial, or the amount of fuel consumed driving 0 miles an hour is 0.09 gallons per mile. Doesn't make any sense, does it? Okay. 50.04. What does that mean? If you drive 50 miles per hour, you are driving most efficiently with this vehicle. Is that true for all of y'all's vehicles? Mine gets the best gas mileage at about 68. So if I go a little slower on the freeway than 70, I maximize my fuel burning. Anybody have an opinion about how?
I think mine's around 60.
60?
Yeah, 60.
60? Felicia, you got an opinion?
Not really.
My father-in-law used to say his best gas mileage was at 55, and so he would come and visit us. They lived in western Minnesota, and he would say, yeah, I drove 55 the whole way here. I got such good gas mileage. And I was like, did you take the freeway? Well, yeah, but just while I was in Wisconsin, because I like to drive on the back roads in Minnesota. It's like, but Grandpa, if you're driving 55 and everybody else on the freeway is driving 65, you're going to be making a lot of people angry. Okay, page 208. Label your axes of your graph with the names of each quantity and their units. So here we go. Our speed goes from 15 to 85. And that's in miles per hour. And our consumption goes from 0, I put up 0.1, and my graph went like this. And I'm going to label this point 50.04. We'll start there after our break.
Yeah.
Oh, I could hardly wait, Kevin.
My legs are falling asleep. Let's
You
get
have to
rolling.
walk around. I got to remember to mark Jessica present.
People
Oh,
close up
yeah.
yeah.
Oh yeah, a lot of people.
News story. Oh,
So you don't have to see this story.
because it wastes my Wi-Fi. My dad is voting out. I want to see the important people, so I don't know what's going on. I don't like that. But yeah, I just want to go. This is just too many. And the news sometimes happens. And then 10 minutes later, I'm just and then I swear.
What was the window you entered for the last equation, if I may?
0.1 positive or negative to 0.1 positive.
Okay.
How do you use these?
Denominator equals 0. And it's that never works for me. Wait, we'll add this out. I mean, that's already right.
But it doesn't come with a sheet. Wait, yeah, it does. The root. Is that what you mean? No, what do you
So, no, this is the example.
Nice.
Oh, yeah.
It's not.
Wait, 7 over 6.
Wait, so this would be 2
My brother's going away to that class,
Like this is 1 plus 1.
and he definitely didn't come to class today.
Right?
And then we'll see what the
6 and minus 3 is 3.
Oh, yeah. So you just you have a paper, so it'd be
And it's just, I want it, and then that gave me an underbid of the bills. Because it wasn't
Take
two
bags
backwards and broke it, because it was so bad about
is.
Are you sure this is?
So now you really don't.
Yeah.
No.
Oh, okay. Basically.
You just have to solve the bottom, like equal it to 0.
I thought that was funny.
0 and 0. Because that's what it is.
She just needs to plug it in.
Oh, it's good.
So this, I guess I'll do like plug it in and then push the feed button. Okay. So
When you press table, how do
you go. Well, you go like right here, and then all like there's like a one right next to those.
and you just
So yeah, I just figured it out. I'm gonna be better at using these apps.
Okay. According to this model, at what speed does the SUV run most efficiently? 50 miles per hour. Well, let's write it this way, 50 miles per hour. To what gas mileage in miles per gallon does that compare? So on our calculator, we would press 0.04 reciprocal key, because now we're going the other direction, and it would be how many miles per gallon? 25. If it has an 18-gallon tank, how far can it go? Are you coming in? How far can it go if it has an 18-gallon tank? How did you figure that out, Eric?
I multiplied 25 by 18.
Since it goes 20, since it's got a, it goes 25 miles per gallon, and it has an 18-gallon tank, it will go 450 miles on a tank. Number 5, suppose that it starts with a full tank, travels at the optimum speed until it runs out of gas. How many gallons of gas does it use per hour? Equals blank gallons per hour. Well, we know for sure that it was going 50 miles per hour, right? And it burned, and it went for 450 miles. Notice I put the 450 miles in the denominator. Okay? Times 18 gallons will give me my miles, or my gallons per hour. So on our calculator, we would press 50 divided by 450 times 18, and we would get 2 gallons per hour. Well, is there another way we could have figured it out? Since it goes 50 miles per hour and it burns 25, or its mileage is 25 miles per gallon, right? It'll burn 2 gallons during that hour. Makes sense? So there's a number of ways to figure that part out. Give a formula for the function gas consumption as a function of velocity that inputs the speed and outputs the fuel consumption in gallons per hour. Well, what is that? It's our consumption function, right? Times our velocity. Right? Because if we got 25 miles per gallon times 50 or 0.04 gallons per mile times 50 miles per hour, we will get that many gallons per hour. Well, what is our formula for C of V? We just had that previous page. V minus 50 squared over 50,000 plus 0.04, and now we're going to multiply that whole thing times V. So that's our formula. Let's enter that in Desmos and see what we get. Where'd my Desmos go? There it is. So if we enter that, take the speed times that other function, notice it hardly graphs on our graph at all. Well, what's the reason for that? Let's think about it. This is how many gallons we're going to be consuming per hour. Well, it's certainly going to be way more than 1/10 of a gallon per hour, right? In fact, it could be up to like 3 or 4 gallons per hour, depending on how fast we're driving. So let's make it go from 0 on the y-axis up to, say, 10. See what that gives us. Well, that's a little bit too much. It looks like it doesn't go any higher than 6. So let's go up to 6. When we did, do you see that our consumption equation, Hertner, disappeared? But the other thing that I'd like to show you is, look at the shape of our graph. Is it a parabola? No. What is the highest power? Looking at your function, highest power is to the third. And notice over here on the right-hand end, it's going up because our leading coefficient is positive, right? So it's going up. But what's it showing here? Well, it's showing that as you go faster and faster, your fuel consumption gets bigger and bigger. Now, not at first, right? At first, it goes up a little bit, and then it seems to level off here in the middle. And then all of a sudden, as you go faster than that, you really, really, really burn fuel through the fuel. Now remember, this is per hour, right? So let's sketch that graph on our paper. This is fuel consumption per hour. Okay? Now what's interesting is that in calculus, when we take calculus, we'll be able to find how much fuel we burned, because remember, this is fuel consumption per hour. Well, during the first hour, we burn this much fuel. I'm sorry, going at this speed, we burn this much fuel per hour. And then we just can see that all the way along here, we can find out what the area underneath that curve is. We're not going to do that today, though. According to this graph, how does increasing the speed affect the consumption in gallons per hour? Is this effect different when increasing from 35 to 50 versus 50 to 85? So let's look here at our graph. So we will do 35 to 50. So that's 15 miles per hour. So here's the slope from 15 or 35 to 50 miles per hour, right? It's about that much slope. What happens from 50 to 80 miles per hour? Much steeper, right? Or 50 to 65. So it wants us to fill in each of those spots on the table on this page. So let's make the table. We've got 35, 50, and 65, and C of V, and distance, and G of V, and T. Okay, so let's start with the consumption at 35, which is right here, and 35 is 0.044. Consumption at 50, we already know, is 0.04. Consumption at 65 is also 0.044. So, whoa, that's got to be reset. So the amount of gas that you burn per mile is the same if you're going 35 as if you're going 65. If that is true, why do you guys like to drive 65 miles an hour rather than 35 miles an hour?
To get you there faster.
Because you spend less time on the road, you get there faster, right? Since you get there faster, would you agree you're going to be burning more fuel per hour at 65? Right? Okay, well, let's find out how much fuel you are burning. Oh, how far can you go? Well, since it's 0.044 gallons per mile, and we have an 18-gallon tank, 18 divided by 0.044 gives us 409 miles. So this one would also be 409. You can still go 409 miles. How far did you say, Eric, this 50 miles an hour was? 400? 450? Okay. Then it says the consumption. So let's look at the consumption per hour. Well, if you look here at 35, the consumption is 1.557. The consumption at 50 is 2 point, oops. Wasn't it exactly 2? Yeah. The consumption at 65, 2.893. Okay. Time. Ideas on how you would find how long it takes you to run out of gas. That's true. But I meant mathematically here with this situation.
I like your way better.
Right?
You just have to divide the total amount of gallons by how many gallons an hour it has.
Oh, that would be one way. We know we're going to go 409 miles before we run out of gas, right? How long will it take us to run out of gas? 409 divided by 35. Okay, so let's do the math. 409 divided by 35 gives us, it'll take about 11.6 hours to run out of gas. 11.7. At 50 miles an hour, well, we already figured out that was 9 hours to run out of gas. At 65 miles an hour, 409 divided, 409 divided by 65, it will take us 6.3 hours to run out of gas. But what's going to be true? We're going to probably be done with our trip before that 6.3 hours is up, if our trip is less than 409 miles. So all of those factors work together, and we're going to be seeing that throughout the rest of the course, how those things work together in figuring out those relationships, those average rates of change. On an open road with no traffic, is there ever a reason for a driver to drive slower than the speed limit? Well, I'll ask you this question. Do you know of anybody who has ever gotten picked up for speeding even though they were going slower than the posted speed limit? Nobody knows of anybody.
Yeah, they were.
How?
They were in a big city and they were going slower than the speed limit, and the officer pulled them over because they were basically a hindrance to the traffic.
Okay, that would be one example, but that's not the one I was thinking of. Usually, the officer is there giving you a ticket for it at the same time that the tow truck is there. Now, do you know what I'm talking about? People can get a ticket for driving too fast for conditions, okay? So even though the speed limit says 35, if it's icy out, don't be driving 35. We are going to compose models. Here is our model that we composed last time. We took consumption and we took fuel consumption per hour. And if you notice, the only difference was we multiplied the consumption by the speed. So then they wrote this in standard form. G of V equals 0.00002 v cubed minus 0.002 v squared plus 0.09 v. Are there not outlets in the back wall there? There's just that one right in the middle. That's the only one? Wow. I'll bring up an extension cord. Especially since you went all the way to your car to get your charger.
Me?
Yeah.
I was talking about my phone charger.
Oh, your phone charger. So you are electrically deficient, huh?
Apparently.
Lucky thing you don't run on electricity. Wouldn't that be terrible? Kevin, I can't finish the test. I'm out of electricity. Here we go. Suppose that Jordan drives the SUV for 4 hours at a constant speed of 60 miles per hour. What is his fuel consumption in gallons per hour? So G of V equals, and actually we know that V is 60. Substitute in and see what you get. Ooh, I must have made a mistake. Point zero. Oh, I didn't have enough zeros at the beginning. Should have had 4 zeros in this first part. And then for the second part, I should have had 3 zeros. There we go. Or 2 zeros, I'm sorry. And it's still negative. Oh, I see why, because I missed my 2 here at the very beginning. Did you get 2.52?
Yep.
2.52 gallons per hour. So since he goes for 4 hours, how much fuel does he burn? So if we were going to do a graph like they did on this page here, where they have hours and velocity, time and velocity, for that whole 4-hour period, he was going 60 miles per hour. Actually, I put that in the wrong spot, but that'll be okay. He was going 60 miles per hour. And he burned, I'm going to make another graph at the same time. He burned 2.52 gallons per hour for that whole time, correct? The total amount of gas that he burned times 4, what do you get? 10.08 gallons of fuel he burned. Are these reasonable in the context of this problem? Seem like it, right? Next, now suppose he drives for 2 hours at 55 and then 2 hours at 65. Question number 1, does he end up at the same spot that he did before. 4 hours at 60, how far down the road are you?
240.
240. 2 hours at 55, 2 hours at 65, how far down the road are you? $240, right? Here's a way to think about it, and that is, here's how much area under the curve he was short by driving at 55. Here's how much area under the curve he made up by driving 65. What's true about those two areas?
They're equal.
They're equal, right? So the amount that he lost is equal to the amount that he gained, so he's in good shape. How much fuel does he burn during this 4-hour period? Well, for the first 2 hours, he's burning fuel. Let's go back to our graph so that we can get the rate. For the first 2 hours, he's driving 55. And at 55, his fuel consumption is, oh, come on now, 2.228. 2.228 gallons per hour. At 65, he's burning 2.893. So, how do we do the math to find out how much he's going to burn in that whole trip? What could we do? He burned 2.228 gallons per hour for how long? 2 hours. So we'd multiply that by 2. And multiply the other one by 2 and add them together, and what do we get for an answer? So it's 2.228 times 2 plus 2.893 times 2, and we get 10.242 gallons, right? So even though you arrive at the same time, same place, you're burning gas a little bit faster. And I tried to show that here to show you that at the beginning, the amount that he was burning less wasn't quite equal to the amount that he was burning more in the second 2 hours. Do you see that? The way that I graphed it? Okay. Next. Suppose you use a speed function, but the speed was given as a function of time. This is an example of a function composition. So h of t is g of v of t. This function inputs the time and outputs the fuel consumption in gallons per hour. The graph of h1 of t versus t is shown. Okay? So they show the fuel consumption here, just like the one that I drew down here. This is the function h of g of t. Or you could write it h of g of t. Input a time, output a fuel consumption, and you will have the total fuel, or the average fuel consumption graph. Here's the question. What is this area under this graph represent? Well, if you go back here where we had 2.52, times 4, that was the amount of gas that you burned. So the area under this graph is gas burned. What's the area under this graph?
So your distance.
Very good. Distance driven. Now, suppose that Jordan's speed is going to be $10t plus 40. In other words, he's going to start out driving 40 miles an hour, and then each hour he's going to be going 10 miles an hour faster. So after 1 hour, how fast is he going? 2 hours. 3 hours. 4 hours. Why don't we have to do 5 hours? Well, that's one reason. But more importantly, he's only driving for 4 hours. The first question is, on the interval from t equals 0 to t equals 4, use a graphing calculator to graph that function. So if we graph here we go. If we graph that line, y equals 10 times x plus 40. You see it's a linear function. Starts at 40, has a slope of 10. Everybody's good with that, right? Then it says, number 7, give a formula for h of t. Okay, so let's start with our two functions. Our first function is g of t. And if you recall, g of t was that 0.00. G of v was right here. Yeah, g of v was 0.00002v cubed minus 0.002v squared plus 0.09v. V of t is 10t plus 40. So we're going to take this and put it into each one of these spots in this equation up here. So let's put it in. This, hey, you guys, this is an important exercise for you to get used to, because on the test, this was a question that a lot of folks got wrong because they didn't see you actually have to go through the process of putting that in there. And here's a way to help you do it. Put in the numbers, 0.00002, and put in the cubed. But leave a space. Minus 0.002, leave a space, and write the squared. Plus 0.09. Change colors. And put in 10t plus 40. 10t plus 40. 10t plus 40. So they're trying to show you that that function that's how that composite function works. You do not need to simplify your formula, it says, but it does say enter it on your graphing calculator or app. thought I put it in here someplace. Oh, there it is. So here's my function on in Desmos, 0.0002, and then I put in the parentheses 10t plus 40, minus 0.002 times 10t plus 40 squared, and then plus 0.09 times 10t plus 40. First of all, what's the highest power? 3. Leading coefficient, positive. So that means it's going to be right-hand behavior is positive, left-hand behavior is negative because it's an odd power, so it's going to start and end in opposite directions. What does it mean? It means that the where'd my page go? This is outputs fuel consumption in gallons per hour. So this is how many gallons per hour you burn. If you're going for 0 hours, you burn this much, and as you go faster and faster, you burn more and more gas. Fuel consumption in gallons per hour. C of V was gallons per mile. G of V was gallons per hour. H of T is gallons per hour also. Actually, no, this one was G. What was G function again? G of V is gallons per hour. Yeah, okay. Page 211. Sketch this graph on top of the graph on question 4. Make sure you pay attention to the scale of the vertical axis. So we're going to go from 0 to 4 hours, and we're going to go from 40 miles per hour up to 80 miles per hour. And when we do, 40 starts down here, and our graph is going to look like that. One thing that we can't figure out is we do not have the math to figure out what the total consumption is, nor do we have the math to figure out what the average consumption per hour is. But one thing that we can do is compare this area that we saved driving slower to this area that we lost by driving faster. And if you notice, what do you find? The amount you saved doesn't compensate for the amount extra you burned. In other words, you're going to be burning more than 10.24 gallons per hour. But that is in another class called calculus. Why does driving this way consume more gas? Because you're driving faster. I think you get there at the same time, right? If you looked at the average rate of change, because you start out going 40, let's get a You start out going 40 and you end going 80. So the distance that you go, this area here, is equal to this area here. Right? You spend as much time going, or as much distance going slower than 60 as you do going faster than 60 later on. Page 213. Fractional exponents. We aren't going to spend a lot of time on fractional exponents, but I will give you the rules. Exponent. If you multiply numbers, you add their exponents. So, 3 to the 5th times 3 to the 8th is 3 to the 5 plus 8, which is 3 to the 13th. Good. If you divide numbers, you subtract exponents. So, 4 to the 7th over 4 to the 9th is 4 to the 7 minus 9, which is
-2.
4 to the negative 2. Negative exponents are reciprocals. So, 4 to the negative 2nd is the same as 1 over 4 squared. Fractional exponents. The root is the denominator. The numerator is the power. So, 5 to the 7/3 is 5 to the 7th cube root. Page 215. An ice cube maker is promoting a new, larger ice cube. The company claims that the cubes have twice the volume of a regular ice cube and they will cool your drink more quickly. So here's our ice cube. C1. It says C1, suppose the length of each side of C1 is X. Then volume of C1 is
C1 to the third.
x to the
X.
third. Very good. X to the third. Write the volume of C as a function of x. So we would say V as a function of x is x to the third. Then it says change this function to the opposite direction. Since we had such a terrible time with it last time, let's do it the long way again. What did we do to x? We took it to the third, and we got x to the third. Now we're going to start with volume. How do we undo that function?
Cubed root.
Cube root. So we would say x as a function of volume is the cube root of the volume. Now, the thing is, I don't like the way math, because it's not just our book, but all of them do it this way. They don't write it that way, they write it this way. The volume -1 of x, which you can understand that. They switch the x and the v, but they write equals the cube root of x. But that's not really true. It's not the cube root of x, it's the cube root of the volume. But if you switch them around, this is actually the input. So really what they should be saying is the cube root of the input, because the volume is the input there. Okay, part C. The surface area affects how fast it cools. So what is the surface area of this cube?
That's 6x squared.
6x squared. So s as a function of x is 6sx squared. Okay? Now it says write the surface area as a function of velocity. And velocity as a function of volume. Surface area as a function of volume. Well, we're going to take our 6 and we're going to square something. I'm going to change colors. What am I going to square? This right here, correct? 6 times the cube root of the volume squared. Suppose a second cube has twice the volume. So you agree that part is going to stay the same. You agree the cube root is going to stay the same. You agree the v is going to be there. The only difference is this number is going to be a 2. So the volume is going to be double. Oops, it's going to be a little bit bigger than that. So each one of the dimensions is going to be bigger. Not twice as big, just bigger. Okay? And that's hard for folks to understand, that it's not twice as big. I should have brought up my cubic foot. A cubic foot is 1,728 cubic inches, but it's only 1 inch bigger in each dimension than half that amount of volume. It's really, really close in size. Okay, let's see what the math is then. So the volume doubles. let's see what happens to the surface area. Well, when you simplify this, this is the same as 6 times 2v to the 2/3. What is 2 to the 2/3? So even though the volume doubled, the surface area only increased by 1.59 times as much. Twice as much volume, surface area increased by 1.59 times as much. We did not get all the way caught up. 15B is where we'll start on Monday. Happy Thanksgiving.
Yeah, you too.
You too.
Have a jolly holly Thanksgiving. Gotta get my Christmas lights. So do the kids wreck stuff when you're not there, or?
The cats and the dog wreck stuff more than the kids.
Oh, okay. I was just wondering, since they didn't have school, if they were being menaces to society or not.
I took the dog to obedience school. We did well in there, and then it's just a different story when you get home. The only dog that didn't bark at the other dogs there.
Then when he gets home,
Oh, then he just
destroys everything. Is it a type of dog that ordinarily is well behaved?
It's a red Doberman, so
Oh,
they're always busy.
they're kind of high strung.
Oh yeah.
Yeah. Yeah, I don't own a dog, but if I did, I don't think I would like one that would be high strung because I already deal with people. I don't want to deal with animals.
No, he's a lot better than my brother's Great Dane. That dog's even worse.
Yeah. See you guys.
Oh yeah.